If you want to know the true size of a house, counting the individual bricks is a poor strategy. You measure the square footage and the number of rooms. The same logic applies to software. Estimating a project by counting lines of code focuses on the bricks. Function point analysis provides a different approach by measuring the actual features delivered to the user. Unlike simply guessing lines of code, function points require a systematic calculation process. We start by studying the project requirements, identifying specific functions, classifying their complexity, and assigning them numerical weights. That gives us our initial size, which we then adjust for real-world variables. The entire process rests on identifying 5 core functional building blocks. A helpful memory trick is the acronym IOQLI. That stands for external input, external output, external query, also called inquiry, internal logical file, and external interface file. By shifting our focus away from the raw code and categorizing the software into these 5 distinct blocks, project managers can establish a standardized measure of a system's size before a single line of code is ever written. Let's break down those 5 components. An external input, or EI, is any data entered into the system by the user that updates or changes the database. A student filling out a college admission form or a customer creating a new login profile are examples of data flowing inward to update the records. Now, look at how data leaves the software. An external output, or EO, is information sent to the user after undergoing processing or calculation. When a payroll system calculates taxes and deductions to generate a monthly salary slip, that is an external output. Contrast that with an external inquiry, or EQ. This is a simple retrieval of information. The user requests data, and the system displays it without complex calculations. Searching for a student ID to view their current record requires no heavy processing, making it an inquiry rather than an output. Next, we categorize how the software stores data. An internal logical file, or ILF, is a group of records stored and actively maintained by the software itself. A university system's internal student database is an ILF because the system directly controls that data. An external interface file, or EIF, is data the software needs to access but does not maintain. If an online shopping site connects to a third-party payment gateway to verify a transaction, the shopping site is reading an external database it does not own. Every feature requested in a software project will fall into one of these 5 categories of data movement or storage. These are the raw materials we need for our mathematical calculation. Identifying the function is only the first step. Building a comprehensive tax filing portal takes more effort than building a simple password screen. Therefore, every identified function must be classified by its complexity: simple, average, or complex. This chart is the standard function point weight table. It assigns predetermined numerical values to a function based on its type and how difficult it is to build. Notice how the assigned weight increases as the complexity of the task increases. With our functions identified and their weights assigned, we calculate the unadjusted function points, or UFP. We do this by taking the number of identified functions, multiplying them by their assigned weight, and summing the total. Let's run the math. If your requirements document outlines exactly 5 simple external inputs, and the table gives a simple EI a weight of 3, what is the value? We get 15. We repeat that exact calculation for the remaining components. Let's add 15 for outputs, 6 for inquiries, 20 for internal files, and 5 for external files. Adding those together gives us a total UFP of 61. This score of 61 represents the functional size of the software, but it assumes all development environments are equal, which is never the case in practice. 2 systems might have the exact same functional score of 61, but require different development efforts. One might be a simple internal tool, while the other requires heavy encryption, continuous backup recovery, and massive distributed data traffic. To account for these environmental demands, we apply a multiplier called the Value Adjustment Factor, or VAF. This factor is calculated by scoring the system against 14 general characteristics, allowing us to mathematically adjust for non-functional complexity. The final calculation is straightforward. If our unadjusted function points total 80 and our system's specific technical demands yield a value adjustment factor of 1.10, we multiply them together. We arrive at a final function point score of 88. By breaking a project down into 5 distinct behaviors, scaling them by complexity, and adjusting for the environment, function point analysis delivers an objective, language-independent metric of software size. This number serves as the essential starting point for determining the effort and resources a project will eventually require.